Yeah. Hi guys. So in this capsule we are going to find out how to calculate the radius. Okay now? Excuse me. Yeah. How to find out radius of curvature. Okay, we are going to find out radius of curvature. So here you should remember one thing in your mind. If radius is constant, right, while you are moving any object in curve path, if the radius is constant, definitely it will have circular track. It will complete its path in circular track only, right? If r is variable, if it is r is variable, then what happens? Then it will have curvilinear path. Okay na? Right? For example, this could be the path, right? It can move like this or somewhere like this curvilinear. Here the radius is not constant. If you observe this at this point, the radius will be very small. At this point the radius will be large, right? Now what you do is let's have how the radius changes. If you observe carefully at this point, see, right, exactly it is matching, right? Now here if you observe, if I draw a straight line, if I draw radius for this point, okay, so this is the radius at this point. So this radius is called radius of curvature at that point, right? So if you want to find out radius at this point, then let us see here how it would be, right? Now it is matching here, right? Now here if I draw radius at this point, if I draw radius at this point, then this could be the radius. This is the radius of curvature at this point, right? This circle radius will be the radius of curvature at this point, right? So here this is nothing but if the radius of curvature, if the radius is not constant, this is how you will take a different curvilinear tracks, right? So now here in JEE mains and advanced, they very importantly they'll ask while projecting an object, they'll give data how much initial velocity they have projected. They'll give initial velocity, this angle, how much with angle they have projected, everything they'll give, and they'll ask you what is the radius of curvature after t time, or else at the maximum height, or else here. So if whatever the place, whenever they are asking radius of curvature, first thing you should do is just imagine if it is a curve radius of curve, if it is the, okay, exactly what is this, yeah, it is matching, exactly touching, right? So here the radius of this circle will be radius of curvature at this point, right? So here first thing what you have to do is you have to find out velocity at this point, right? You have to find out velocity at this point. You have to find out tangential velocity at that point. After finding the velocity, how do you calculate this velocity here? You know already, you have learned in the projectile motion, right? First you will find x component. You know that x component is always constant, right? X component is always constant. So here this is the x component, right? And then this is the y component, okay? So now here this is nothing but vx, this is nothing but vy. Now v bar is equals to vx I cap plus vy j cap. After finding this, you can able to find this angle alpha also, right? What is tan alpha? Tan alpha is equals to nothing but vy by vx. Now here after finding this, this is nothing but perpendicular velocity at this point for this curve, isn't it? So now here the centripetal acceleration is always towards the center, right? The centripetal acceleration is always towards the center. So now here let's have very small one, okay, yeah. So the centripetal acceleration is towards the center, it is always, this is nothing but centripetal acceleration, okay na? It is towards the center, clear? Now here at any time acceleration due to gravity always towards the ground, right? And this is nothing but g. Here at this point centripetal acceleration is nothing but, if it is alpha, then this also will be alpha only, right? So because these two are perpendicular, that's why, and these two are perpendicular, so if it is alpha, this angle will be also alpha. Then I can take this component as a g cos alpha, right? Here g cos alpha is towards the center of this circle. That is why this g cos alpha is called centripetal acceleration. Hope it is very clear. Okay, na? It is called centripetal acceleration. Now here we know very well the formula. Centripetal acceleration is equals to only centripetal acceleration, right? Centripetal acceleration is equals to nothing but v square by r, right? V perpendicular, right? V square by r. This is the radius. R is the radius of this circle, right? Now we know very well AC is nothing but g cos alpha. G cos alpha is equals to v square by r. So from this r is equals to v square by g cos alpha. Okay, here sometime in the question they'll give this alpha. If they don't give, you have to find out this g cos alpha. Okay now, so now here this is how you have to calculate the radius at any point of the curvature. Clear? Now let us solve a few questions. For example, if he asks exact at the maximum height, at maximum height the velocity is nothing but v cos theta only, right? V cos theta, I mean if you project with u, then so let us take u cos theta only, right? U cos theta, because initially whatever the velocity you projected, that x component is nothing but u cos theta. In this direction it will be u cos theta, and initial velocity along with y axis is u sin theta. So here you should remember that horizontal component never changes. So this is u cos theta, right now. So here directly you can find out here, right now. Then in this condition, centripetal acceleration is nothing but acceleration due to gravity. That is why g is equals to centripetal acceleration. G is equals to v square means u square cos square theta by r. So from this r is equals to u square cos square theta by r. So sorry, g, right? This is the method to find out radius of curvature. At any point you can find out. So you have to know how to find velocity at any point. To know this, you just observe my lecture in a kind of motion plane, you will get it. Okay na? So now let us try to and one more point also you can observe here. You can apply one more important point also. That important point is here, just imagine if it is velocity v at this point, then vx is equals to, how can I write? Vx is equals to nothing but v perpendicular cos alpha, right? Vx is nothing but v cos perpendicular cos alpha. And here I know that x component never changes in a projectile motion, right? But because of that I can make it equal to u sin theta na? I can make it equal to u sin theta. So from this you can directly calculate v value. So what is v value? V is equals to u sin theta by cos alpha. Clear? U sin theta by cos alpha. So by using this equation also you can find out v. Okay na? You can find out v, or else they'll give hint to find out cos alpha. If you want to find out alpha, by using this also you can find out. For example, cos alpha is equals to u sin theta by v, right? So based on these relations also you can able to solve the problems, right? Now let us solve one problem. Based on this, right? And then we can close this. What is the radius of curvature of the parabola traced out by the projectile? In the previous problem, at the point where the particle velocity makes an angle theta by 2 with the horizontal. So something previous problem he said here, but I don't know that, just I thought it is a problem. Okay, let us see, let us find out. So here just imagine we have a projectile motion in this direction, right? So x-axis, y-axis, okay, and then for projectile motion, what I'll take is projectile motion, right? So from here to here it is, and this is the projectile motion. Yeah, let's key here, and let us draw initial velocity also, right? This is the initial velocity, and this initial velocity is making an angle theta. It is making angle theta, and this is u bar, okay? And we know very well this u bar can split into u cos theta and then u sin theta, right now. So now here after some time what happened, the object reached here. At this point, what is the velocity? The velocity is nothing but this is the velocity, and this is nothing but, let me draw somewhat, okay? So this is a v at this point, and this v can split into two components, right? One is vx and another one is vy. It can split into two components. Here you just imagine this is v at velocity at this point, and here in the question itself he said, in the question what he said, point where the particle velocity makes an angle theta by 2 with horizontal. So here he mentioned the angle between, he mentioned the angle between horizontal and the velocity. This angle is nothing but theta by 2. Then this is nothing but v cos theta by 2, and this is nothing but v sin theta by 2. Okay, it's clear now. We know very well v cos theta by 2 should be equal to u cos theta, because we know very well horizontal velocity component never changes. From this you can have v is equals to u cos theta by 2. Okay, so this is a v. And now if you want to find out radius, just before we have taken one equation, right? What is radius of curvature formula? R is equals to v square by, what is the formula? R is equals to v square by g cos alpha, right? R is equals to v square by g cos alpha. So same way you will have here, so same way we'll have here radius r is equals to v square by r is equals to v square by g cos, what is alpha here? Theta by 2, cos theta by 2, that is equals to, what is v value we got here? U square cos square theta, u square cos square theta by cos square theta by 2 by v squared, okay? Then g cos theta by 2, right now. So from this r is equals to nothing but u square cos square theta by g cos cube theta by 2. Clear? So now of course you can furtherly also solve this if you want, right? You can change the cos theta values, and cos square theta is there, right? You can change the value, and you can change this into theta by 2 equation, then it will be cancelled. Okay, so thank you. If you have any question doubts, please post below. Thank you all.